Please open in your learning workbook to page 56 and read along as we learn together. To solve a system of two linear equations using the substitution method, choose one of the equations and solve it for one of the variables, whichever one is easier. Then in the other equation, replace that variable with the expression it's equal to from the original. Solve the resulting linear equation in one variable. Then, plug that value into either equation and solve for the value of the other. Express the result as an ordered pair. Alright, let's look at a problem that uses the substitution method. We have the following system. X fourths plus y equals negative 19 fourths. Negative 2x plus 14y equals negative 116. This problem comes with a hint. It says, first, clear the fractions in the top equation, then solve it for x. Alright, so whenever we algebraically solve a system, I find that it is very useful to label both equations, and I do so with 1 and 2 in boxes. I use a box because a box is a non-mathematical symbol, and therefore I will not confuse the numbers 1 and 2 for being part of my problem in my solution. All right, so the first thing we're going to do here is we're going to solve equation 1 for one of the variables, and we're going to clear away the fractions as our first step in doing that. Okay, so we notice that our denominator is 4 here and here. This y does not have a denominator. So our least common denominator is 4. So I'm going to multiply both sides by 4. Now 4 is the same as 4 over 1. And if that becomes convenient for me at any point during my simplification step, I will remember that. All right, so I'm going to use the distributive property on the left. 4 over 1 times x over 4. This 4 and this 4 cancel, leaving me with x over 1, which is just x. When I distribute the other, I remember that this is just a 4 being distributed to a y, which is 4y. Over here, this 4 and this 4 cancel to 1. And what I'm left with is negative 19 times 1 and then divided by 1. Well, anything times 1 is itself, anything divided by 1 is itself, so this is just negative 19. So we get x plus 4y equals negative 19. Now this is still equation 1. It hasn't, we haven't changed equations, we've just changed the look of the equation. Okay, so now our job is to solve this equation for one of the variables, whichever one is easier. Well, right now, the x is the easier variable to solve from because it doesn't have a coefficient. See, this y is a coefficient of 4. If you wanted to solve for the y, you'd have to get it alone and divide by 4. With the x, all you have to do is get it alone. So we're going to solve for this x. And the way we'll do so is by moving this term to the other side. Remember, when a term changes sides, it changes signs. So I get x equals negative 4y subtract 19. All right, so now that I know what x equals from equation 1, the reason why we call this the substitution method is because we will now substitute the value, the expression that x is equal to from equation 1 into any place that we see an x in equation 2. You always substitute into the other equation. So if you solve for a variable in equation 1, you plug into equation 2. If you solve for a variable in equation 2, you plug into equation 1. All right, let's summarize what we've learned so far. X equals negative 4y minus 19. This is equation 1. And negative 2x plus 14y equals negative 116. This is equation 2. And we are going to substitute this in here. So then we get negative 2 times negative 4y subtract 19. Notice the use of parentheses here. When you replace something with something new in algebra, you need parentheses if the thing you're replacing has an exponent or has a multiplying value or is being subtracted. Well, in this case, we have a multiplying neighbor here, so parentheses are required. Plus 14y equals negative 116. We'll now use the distributive property. 8y plus 38 plus 14y equals negative 116. We're going to move this to the other side, and we're going to combine these like terms together. So then that's going to give us 22y equals negative 116 minus 38. 22y equals negative 154. Divide by 22 on both sides. Y equals negative 7. Okay, so we found the value of one of our variables, but this is not our final answer. Think about the previous videos you've watched. Solving a system means finding the collection of all ordered pairs that satisfy both equations at the same time. An ordered pair, a point, has an x and a y. At this point, all we know is the y. We still need to find the x. So we have to pick one of our equations to plug into. And there are lots of choices. If we look on the board right now, we see that this is an equation that we can plug into. This is an equation that we can plug into. This is an equation that we can plug into. Pretty much any equation anywhere in our solution that still contains the variables x and y could be used to achieve our objective. We know the value of one, we need to find the value of the other. So we have a very important decision to make. Which one of these equations should we plug back into? Let's be thoughtful about this. What do we know, and what are we trying to find? We know y. What we're trying to find is x. So the most logical equation to choose from here would be the one that starts with x equals, because what we are trying to find out is, what does x equal? So we're going to plug this into here to find the value of x. Could we plug into here? Sure. Could we plug into here? Sure. But it would be longer and harder to achieve the objective. Okay, so now that we know what we want to plug in and where we want to plug it in, we'll go ahead and achieve that task. All right, here we go. So x equals negative 4y subtract 19, and we're going to plug y equals negative 7 into that equation. So we get x equals negative 4 times negative 7 minus 19. Negative times negative is positive, so this is 28 minus 19, which is 9. So now I know x and y. So my final answer is the ordered pair 9, negative 7. All right, is it possible to check your work for this problem? The answer is yes. Using the previous learning objective, in one of the equations, replace every x with a 9 and every y with a negative 7. Evaluate the left side and right side to make sure they are the same. Then repeat that for the second equation. We've now completed this problem.